In this lab, we will be configuring BGP's MED attribute. This is the topology which you can see on the screen. And this time we will be using CML, Cisco Modeling Labs. And our goal is to get to AS12 from router 1. I'll show IP BGP. This is the BGP table of router 1. And we are advertising only a single prefix in AS12. This is router 12's loopback address, and we have 3 options to get there, either through AS78 or through AS9. And as we can see, basically everything is equal. We have the same weight, which is 0, the same local preference, which will be 100 by default. The prefix is of course not locally originated. The length of the AS path is the same, so we have to go through 3 AS hops to reach AS12. And we either choose AS78 or AS9, and then AS110, and finally AS12. So although the AS path is not the same, the length of the AS path is the same. So we take the next attribute, which is origin code. Again, origin code is the same, which is IGP, and the next attribute, which is MED. So if the MED is not present in the BGP update, it has the default value of 0. So MED is equal, and we take the next attribute, which says prefer eBGP to iBGP, and all 3 neighbors are eBGP. So if everything is equal at this point, which is the case here, we simply take the oldest eBGP path. So probably router 8 came up first before router 7 and router 9. So we take this path. What I'm gonna do first, I'm gonna simply shut down all 3 eBGP peerings towards router 1, one by one. First on router 7, so router BGP 78 and neighbor 192.0.17.1. shut down, and on router 8, router BGP 78, neighbor 192.0.18.1, shut down, and also on router 9, neighbor 192.0.19.1, shut down. Now on router 1, we take the iBGP path and use router 6 as the exit point from AS16. So we have 2 paths which are basically the same, but that's because we have 2 route reflectors. See, the cluster list is different. So as we can see, router 4 and router 5 are the 2 route reflectors, And actually, I'm gonna shut down these two peerings to router 6 as well, because we are only focusing on these three paths. So on router 8, neighbor 192.168.6 shut down, and on router 9, neighbor 192.169.6 shut down. So now what I'm gonna do, I create a route map on router 7 and assign a med value of let's say 100 for this 150.12.12 network, and then enable the peering between router 1 and router 7 again. So first we create a prefix list to match the 150.12.12 network. So IP prefix list, I'm gonna call this simply AS12 and permit 150.12.12.12/32. And now the route map, let's call this med_test, permit 10, match the IP address prefix list AS12, and we set the metric, which is the med, to 100. And because of the implicit deny, I create another permit statement for the route map, which is gonna match everything else. It's not really needed here because we only have this single prefix, but otherwise it's needed. And we apply the route map to the neighbor router 1 outbound, so router BGP 78 and neighbor 192.0.17.1 route map med_test outbound. And finally, no shut the peerings. So no neighbor 192.0.17.1 shutdown. And now let's move back to router 1, show IP BGP. And now we take the path towards router 7 because we don't really have other choice, but we have a med of 100 here, not 0. Now I'm gonna do the same on router 8. So we create a route map for this 150.12.12.12. But this time we set the med to, let's say, 50. And everything else will be equal. So the weight, local preference, AS path, so the lowest med wins. And the path towards router 8 will be preferred. So let's test it. On router 8, we create the prefix list the same way. And then the route map. At this time, we set the med to 50. and we apply the route map to router 1 outbound. So neighbor 192.0.18.1 route map med_test outbound, and finally no shut the neighbor. So no neighbor 192.0.18.1 shutdown. And let's get back to router 1, show IP BGP, and just as we expected, the lowest med wins, and router 8 is preferred to router 7. Well, now let's enable the peering to router 9 as well, and assign a med value of 20 to the prefix 150.12.12.12. So what should happen now? Router 9 should be preferred because of the lowest med, and router 1 should choose router 9, right? Well, let's see. I create the prefix list the same way, and the same route map, except that this time we set the metric to 20, and apply the route map to the neighbor 192.0.19.1 map med test outbound, and no shut the neighbor. So the neighbor is up, so let's move back to router 1 and see what happened. We have received the update from router 9 with a med of 20, but still we prefer router 8 with higher med. But why? So remember, everything is equal. All of the 3 paths have the same weight, local preference, the length of the AS path is the same, the origin code is the same. So we should be comparing meds and choose the lowest one. But we don't. And here is the thing. By default, we can only compare med if the neighbor AS is the same. So we could compare med of 50 to 100 because they came from the same AS. But this time the BGP update came from a different AS, from AS 9. So we cannot compare med on this row to this row. I guess it was designed for stability purposes this way, but by default we simply cannot compare. That's the rule. But we can change this behavior with a single command on router 1. So under the BGP process, and the command is BGP always compare med. And we don't need route refresh or anything like that. It simply takes effect. Let's verify. We'll do show IP BGP. And as expected, now we choose router 9, lowest med wins, because we can compare all of the 3 paths, even though the neighbor AS is not the same, but the length of the AS path is the same. So remember that comparing med is not always straightforward. Sometimes we can, sometimes we cannot compare the med values. Also, it depends on the platform, how we handle the missing med value. On iOS, we simply assign a value of 0 to every prefix without the MED value. On other platforms, we handle them differently and assign the highest possible value. But we can also do that on iOS. Let's test that actually. I enable the peering between router 6 and router 9. So no neighbor 192.0.69.6 shutdown, and move back to router 1. And now we use router 6 as the exit point, because by default we have a MED of 0 if router 9 doesn't send MED in the BGP update. So we go all the way around in AS16 and use router 6 as the exit point. But if on router 6 I use the command BGP bestpath MED missing as worst, now we assign the highest possible value to every prefix without MED value. See, now we have the value of 42 something, I don't even know how to say it, and MED is actually propagated, so it's transitive within the autonomous system. So if I resend the updates, or do clear IP BGP out, so I resend the updates to the two route refactors, and let's check it on router 1. And again, we use the eBGP path with the MED of 20. And also on router 6, if I do route refresh or do clear IP BGP inbound and do show IP BGP, and router 6 should also use router 1 as the exit point from AS16, because again, lowest MED wins, and the MEDs can be compared because they came from the same neighboring AS.